Okay. Basically, the results that Sri showed are the field results, which were based on these in vitro experiments, which I'll show you now, because the better and best fungicides, which we screened in the lab, were tested in the field. And as you can see from the results that Sri presented in the from the field trials, there wasn't very much success. So that's just to cut to the chase. So, okay, basically our fungicide efficacy tests and pesticides, because we tested the pesticides as well at the same time. We tested the fungicides in order to see what pesticides would be taken up by the fungus and eventually devoured or eaten or fed to the insect, and thus circumventing and through the fungus killing the larvae, as shown using our method. So what we did was started off by incorporating, like every pathologist does in the lab, you incorporate your fungicide into the plate, or as it is a pesticide, and we used a random method of just measuring after 10 days, because that's when the plates are usually filled by the fungus. So it grows within about 10 days, it covers the plates. So these were some of the, just to give you an idea, some of the fungicides were effective in such that they inhibited 100% growth, whereas others had no effect, some control as well, which had no effect on the plates. But the concentrations of fungicides that we initiated and started off with were at 10 ppm. So that's our bottom line for plate tests. Anything that was not effective at 10 ppm, we usually discarded. And obviously we went for systemic fungicides, but although I have quite a lot of experience with systemic fungicides injected into mango without much success, also infusion, injection, drench, whatever, I wasn't too optimistic about this, but we had to go ahead with it in any event. So there were a whole bunch of fungicides. We started off with the systemic ones, and we always had 3 isolates, representative isolates in there to screen. And the ones that stood out were prochlorads, which that's one of my favorites, because I work with a lot of Fusarium pathogens, and that's one of the first fungicides I attempt and I try, and it seems to be one of the best. And what's more is resistance to prochlorads has not been reported in the field, and it's been used in many cases against many fungi throughout Europe as well. So it's very promising. Unfortunately, it's not fully systemic, it's just translaminar. It has a translaminar action from one side of the leaf to the other. It doesn't actually move systemically. Tebuconazole wasn't bad either. Carbendazim also gave good results at inhibiting at concentration of 10 ppm, and we had two companies supplying us with tebuconazole in different generic forms, so that was good. So it seemed to be a good compound. And then we looked at the less nasty of chemicals, which are considered some of them even inducers of resistance, for example, the potassium phosphate. Obviously in plates or in vitro, you're not going to see much result, but we were very disappointed with anemics, for example, and none of these were at all useful to take further to the field stage. So again, taking these 3 representative fungicides, at 10 ppm we had very reproducible results in plates, obviously. And then when you reduce the concentration from 10.1, 0.1 to 0.001, we had good results in plates. I mean, concentrations like 0.1 ppm to get a 50% reduction of growth is very good. But again, that's prochloraz and it doesn't really move systemically in the plant. But carbendazim was tebuconazole and the others also proved quite effective in plates. Okay, and then we had another bunch of fungicides. This one we haven't actually tried in the field yet, but metaconazole and also bromoconazole and miclobutanil. All these seem to be quite good at the in vitro level. They still need to be assessed in the field, though. Okay, so this was again using a range of concentrations of the fungicides I mentioned previously. So you can see there does seem to be some fungicides that in vitro have quite good potential besides the ones we tried in the field. So we have further work to do with these at this stage. What was very interesting is what Sri mentioned, this imamectin benzoate also inhibits in vitro fungal growth. So this could have a double effect. This could also affect the insect as well as the fungus at the same time. So this may be something potential as for a protectant in the future in orchards that are not yet effective. So it could serve a double purpose. So initial field trials, which we set up again with Svi, which you already spoke about, were just showing you how we applied some through injection via drip irrigation, through the stem injections and such, drench, for example. So our questions that we still need to address, and these are mainly scientific questions, are how do you monitor initial infection? In other words, you have an infected tree, it's usually infected at the trunk. How do you know what that rate of infection is? Where exactly is the fungus located? So this is something that we still have to consider and think up methods of, for instance, boring in, taking out cores, trying to see exactly where the fungus is located. Evaluation for efficacy as well. How do we measure our field trial for its efficacy against the fungus? How effective was your treatment? Without doing much damage to the tree, obviously, and obviously monitoring the efficacy. Is it long-term, short-term, as such? So we still, all these field experiments were set up basically this season, 6 months ago, so we only really at a beginning. This is in its infancy, basically. That's it. Thanks.
I was wondering, can you use a dye to see like how far the product is moving up the tree?
I don't know. We haven't thought of that at this stage. I mean, that would probably have to be invasive. You'd have to damage the tree, perhaps take out cores. I mean, actually drill in and take out a core and try and plate and find out where your dye is located, or look at the dye.
To add the dye with the
fungicide.
The fungicide application.
I don't know about that.
Just to see where it's moving inside the tree, if it's being delivered where you want it to be delivered.
Well, what we did in previous work was actually doing chemical analysis of presence of the fungicides that were applied to mango to see where they moved. So we may have to resort to an expensive way of analysis, but we haven't done anything like that.
In avocado, there doesn't seem to be much lateral movement within the vascular system. Once you inject above, the root collar, those vascular traces are separated. They're pipes, and there's not movement from one to another. So using those little Fosjet injectors, caveat emptor is you may be doing a really good job treating that cylinder, but then on either side of it, you're not getting much of the product into the tree.
Yeah, in general, when you have hundreds or even thousands of trees infected at that level, I don't know how really economic it will be to actually treat trees. And nobody promises that you're going to get systemic movement of the fungicides we've tested anyway. So yeah, I mean, even if you inject into the flare roots as you've done, I don't know how our fungicides say, okay, maybe your tilt will move, but that doesn't mean that our effective ones will also move.
Well, and the problem with that is it's very expensive.
Yeah, exactly. Yeah.
Stanley, I have a question for you. So have you used any particular fertilizers?
Fertilizers? We used the cannon, which is supposed to be also a fertilizer as well as an inducer to resistance, but at this stage there's nothing that has shown that there's any induced resistance against the fungus that we could see or observe.
Stanley, a lot of the materials you looked at were the DMI fungicides. There's a group that's being registered, the SDHIs, that are being registered around the U.S. extensively now. This group of materials is highly systemic. Have you looked at this group and any? I didn't see any of that whole class of materials in that list.
Well, we try. Are you talking about the strobilurines or?
The SDHIs group 7, frat group 7, SDHIs.
Well, we tried everything on the market in Israel, so obviously it hasn't reached, so.
Okay, any other questions?
Just as a comment, these SDHIs that are using them for powder mildew control as soil applications, so they're highly systemic in silage. It'd be interesting.
Yeah, no, for sure. I'll get the details from you.
Okay, thank you, Stanley.